Can you see my screen? Oh, please. I will not be able to see the chat. I can hear the sound,
yes,
but
we
I
can.
cannot. Okay, thank you. Yes, so walking us through data modeling, and it's more like a basic, even though it's basic stroke intermediate presentation. And what typically a data model is just like how it is in English. You can derive words by breaking them down and understanding what the different words mean. So for data and model, we all know what data is: a collection of raw facts, numbers, and different things. And on its own, data doesn't have any meaning until you process it, you analyze it, and then you can now say, okay, I can derive insight and make informed decision. And then modeling is more like a blueprint, and that's why it's in the title. It's like having a visual representation of something you have in your mind. So for people that are into creative, or maybe, for instance, let's use fashion. At one point in time, you've thought about a particular cloth or design of clothes you like, and you had it in your mind, and then you decided to engage a tailor that would make that into a physical reality. That's how it is. You're just saying, okay, I want this, and I will look for the different materials. I'll be able to, do I want a blouse and a skirt? Do I want a gown? Do I want a shirt and a trouser? So you find those different ideas and different processes in just that little mind or vision you had in a particular design. So data modeling is now together means creating and designing in a visual representation of your data structure and the relationship. So for instance, as a dress, you already had it in mind, you designed it, you went to the tailor, you showed him the material, you want a blouse and you want a skirt, or you want a shirt and you want a trouser, and then you connected the different materials based on the style you want. And then you did fittings. At a point in time, the dress will be sewn, or the top and the bottom will be sewn, and you go into fitting, remove some parts, amend some parts. And this is all about data modeling. And then at the end of the day, you go, whether it's for a wedding, you go for a birthday party, and you showed us what you've been able to do. And then your stakeholders, meaning your friends, your loved ones, your family, then get to appreciate all the strategy or everything that happened. Okay, so this is the agenda: introduction, data modeling basics, essential of data modeling, types of data models, ETL and ELT processes, data pipeline. Then we move on to data modeling in everyday work. Everything that we do, we always use a part of data modeling, just like I explained in designing a cloth and wearing it. And then we have pitfalls and how you can avoid them. And then I will just show a picture of a simple data model. So as data professionals, we always use data, we organize data, but we always need a clear structure on how that data should be. You go into your office, you go home, and you're thinking about an idea. You have to either draw it or come up with a way to create a model of that data or that thought. And that's what data model is you trying to represent it in a way that is easy for people to understand and for you to connect the dots. So if you are, for instance, in the school, you go to the library and you want to pick a book, you want to retrieve a book, and the librarian wants to lend you a book. If you want to design a data model of that, you always know that one of the data you need is the authors. You need to know the authors of the book. You also need to know when maybe the date that it was published. You also need to know the genre. Is it fiction? Is it sciences? Depending on what you are interested in, you also need to know that. And this helps you when you are designing your data model, because you need to know where things are going to go, what are the features that are interested in that. And what the data model will do is to make things simple for you to be able to connect and design a database, because you have to store this data. So when you extract the raw form and you design your data model in terms of how it's going to flow, you need to store it somewhere after you have materialized it or validated it or deployed it. Then you need to store it somewhere, and that's a database. So the data model sits in the middle to make sure that you're able to capture everything that is important. And it also gives you that advantage to have conversation with your stakeholders, to tell them the technical guys said this is what we need to do. Do we have the data to do it? If we don't have the data, you also plan for scalability or future growth. So depending on what you do. And then things that are very important in data modeling are your entities. Those are your dimensions. Those are the things that, like customers, orders, those are the nouns. So when you go into a data model and you're talking about the noun, you're talking about the book, you're talking about, what the noun is, animal, place, or thing. You're talking about those are going to be your dimension, those are going to be your entities. So it's going to be a table. You're going to create a table for your nouns, and then you have your attributes. Your attributes are features and qualities that define your noun. Those are adjectives. So when you're talking about a customer, you're talking about the height of the customer. That is a column. That's also known as a field. That's also known as an attribute. That is your features. Or you're talking about location, demographic. That's also like the city. Are they in Lisbon? Are they in the United States? Are they in the UK? Then you also need to know the key and the unique values. So keys are unique identifiers. So because as data people, we cannot identify someone as just Stanley Igwe. It is important that you have a text, a unique ID that shows that this is Stanley Igwe, because you might just meet me for the first time today, and tomorrow you go to US or go back to Nigeria and you meet like 5 different Stanley Igwe. So what differentiates my Stanley Igwe from the other Stanley Igwe in the data world is the unique identifier. And then we also create relationship between those tables, because now you have a noun, a customer, you have another one, the order. You want to connect the 2 tables together. You need something that is relatable from the 2 data. And when the ID of that particular table, like for customer, it's called the primary key, because the ID identifies the customer in that particular table called customers. And then in the orders table, it has its own primary key that identifies the individual or the unique orders in that table. And when you connect the 2 of them, you need a foreign key. So something that's going to connect the customers to the orders, it's the foreign key in the order table. So we're going to go into that. And then you need the data types. The data types is for every column that you have in your data, there are specific, or there are various types of data. So for instance, you have the qualitative data, that's like categorical data. Then you have quantitative, like numbers. And there are different types of numbers. For instance, you have the whole number, you have the decimal, and then you also have date and time together. You also have date separate from time. So these are different data types that you also need to be aware of when you are using your or designing your data model. And normalization is helping you to get rid of redundancy or duplicate values. So when you have your data, it's important that everything in your data is connected to the unique key, and also that unique key identifies that particular record. That's the row of your data. So when you are repeating values, for instance, you have a city address, you have in your address, you have the city, you have the postal code, you have the country, you have the state. That is a data set that you need to normalize, because normalization helps you remove that, so that you can also in the reporting side, you can analyze the data based on city. So you just don't have address as one column. You split the address to the house number. You split it into another column that tells you the city. You split it into another column that tells you the postal code. You split it into another column that tells you the state, and you split it into another column that tells you the country. So it different forms of normalization, and they build on top each other. The normal form 1, the normal form 2, normal form 3, up to 6. But normally and usually people only use the normal from 1 to 3. So nobody does 4 to 6 because it gets complicated. And that's where another word called denormalization comes into place, because sometimes when you are trying as much as you can to capture every fact of your or every component or entity in your model as a table, you get to reduce it, the speed, the performance of your data model or your data query drops, because now you have to create joins with different tables to extract data that you will normally have in one table and just take them out. Okay, so the basic of data modeling, I explained most of this, is the entities, the attributes. Entities are nouns, attributes are adjectives. So when you think about it, when you want to go into a discussion or conversation with your stakeholders in terms of designing data as a business analyst, because the first level is like you having it with the stakeholders and business analysts. Those are most of the time non-technical people. And then the second level is getting into a little bit of technical people. I don't know, I'm hearing some messages. You can tell me what it is if you need my attention, or people are just joining the meeting. Okay, and then we have keys and unique values that are the primary keys, the foreign keys. So you're connecting one particular table to another table. The primary key of that particular unique value in that original table is the primary key. Then the one in the other table is the foreign key. Then your relationship. And this is funny because most of the time, even me, when I started my data journey, I would normally refer to relationship as one to many, many to one, many to many, one to one. Relationship is literally what tells you that this table is related to this other table. When you start talking about the quantitative information about whether it's one to many or many to many, it's now called cardinality. But at least when you're just starting, you can refer to both of them as relationship. But going deeper, you know that there's a difference between just saying relationship and you're talking about cardinality. Cardinality is when you now have a quantitative number to the relationship that exists between two tables. Relationship is just telling you that, oh, that's the language your business analyst or your stakeholders or subject matter expert will use. That, oh, remember that when the student comes into the school, they can collect a book from the shelf or from the librarian, and one author can write different books. He's just telling you how those different entities are related, but you as the technical person now design the cardinality and know that, oh, one student can only pick one book until he has returned the previous one before he can now collect the other book. So what it means is that one student can take as much as 10, 20 books. So if you're connecting the table of students to the table of books, it's always possible to have one to many, because it's only one particular type of student, whereas the student can collect as much book as he can or she can. And then you have the data type that tells you the different columns and what the content of that column holds. So is it a qualitative data? Is it a date and time? Is it a binary data? Is it numeric data? Then you have your normalization. Yeah, this is like the brief explanation of one normal form that tells you that you need to have one value per cell. So for instance, like the address, you need to break the address down and make sure that you're capturing one information in one column and not merging them together. Another way we do it is if you see a table where there is a column called orders, and then you see another one that is order 1, order 2, order 3, order 4. That table design is wrong, because what it means is that the orders table is repeating. You should create a new table called orders and link it to a unique ID. And when you link it to a unique ID, all you need to do is to relate those two tables together. And when you pull the customer name, it will always find the number of orders that the customer has had in the orders table. So you don't need to have all of them in one table and repeat the columns. Order 1, this is the or day 1, day 2, day 3, day 4. Once you have those kind of table in one, and most of the time in Excel, it's something that you need to do differently as a data modeler or a data engineer or analytics engineer. That's another conversation. There's different titles for very similar roles, and most of the time it depends on the organization where you find yourself. And then if we move on to the next one. So if you want to understand the data modeling, it's important that the first step is to always engage with your stakeholders. They are the ones that have the best knowledge, except you have worked in that particular industry before, so you have some domain knowledge on that. But if you haven't, it's always important to discuss with your stakeholders and have a sheet of paper or a whiteboard and discuss all the tables, all the entities, all the dimensions, and what are the fact tables and how they relate to each other. Then it's something else. How you draw the data model is called entity relationship diagram. There are different tools to do it. You can use Power BI, you can even use Excel, but using the Power Query version to create your entity relationship diagram. And there are other tools that is the only thing they do, like diagram.io. I recently saw that one. That one is nice because you can use it and use ChatGPT and it will write the code for you and create a massive model or very few hours. And then also something that's important is the consistency and integrity of your data. You need to ensure that you have unique IDs. You need to ensure that you have constraints. So for columns that are unique and their IDs, you need to say, okay, there should not be a null value. And something that I need to point out is that null is a state. Null means that there's nothing that exists here. So null and blank are not the same thing. So you need to have some constraints that say, oh, this column, there's nothing that is here. And for IDs, you're not supposed to have a null value as an ID. It's going to flag as an error in any system. So those are also part of the checks that you do later on when people are imputing data into. That's why if you go on like a website and you are typing in some digits, you will notice that some digits are required. There's an asterisk that shows you that you cannot leave this column or this space blank, because at the back end, it's just like rows and columns. They're collecting that data and it has already identified that this is a test or a check. This column can never be blank. The customer, the student, the voters must fill this information so that we're able to collect it. And then you always have to leave room for flexibility and growth. So when you're designing a model, you always have to leave room for in future, if something is going to come up, how are we going to capture that data, discuss about that so that it helps you later and you know that you're not having to do much after. And then there are different types of data models. There's one called conceptual model. That's the first level. The second level is the logical model. The third level is the physical model. And the advantage of all this is that they build on top of each other. So when you're having the conversation with your stakeholders and with the business analysts, the people that only speak business language, you're talking at the conceptual level where you're just saying that, oh, a customer will place an order, the order will go to the cafeteria or the restaurant, they will prepare the meal, and then the rider will come and pick up the order, and the rider will take it to the customer, and deliver it. And it's only when the rider, and nowadays you notice that some, depending on the platform that uses it, there's some platform that asks the delivery man to also put a code. So only until he has collected that code from the customer to insert that order has been fulfilled. So those are the languages they speak. But you know that you cannot just type that and just put it in any system and it will create the data model. So that's the first level, the connection of how the order takes place. The customer, the delivery man takes it, the restaurant takes it, the customer finally gets the order. That's the conceptual model. Then the logical model is now when you're saying, okay, when they deliver, when they order, what are those features or what are those qualities that the order needs to have? Then that's when you go into, okay, it's buy one, get one free. Or I know some people I am ordering a lot now. That's why I know a lot about this. So it's buy one, get one free. Or you say, okay, it's a vegetarian. It doesn't take meat, or it doesn't do this. Or you say, okay, this food comes with fish, chicken. And you know, when you're selecting this on your order, you see that there are options that you need to select. There are some that are required. Or when you choose the option menu. So those are just like the logical part. You are now giving them more information about what the order is supposed to look like and what are those other columns that will exist in the order. Is it a buy one, get free? Is it a vegetarian option? Is it that? So you are giving more information about that. And then your physical model is when you now put everything together. You relate the tables from the order to the delivery. You put the unique ID so that you can connect the two tables together. So that's the last level, whether the data engineer or the analytics engineer or the data architect, depending on the company, that's when they design the full detail of the model. So they build on top of each other. And then there's something known as ETL or ELT process. This helps in terms of when you're designing your model, you also need to know how the data comes in, how you plan to transform the data, and how you plan to load it into a database. And something that has happened recently is that we have switched from most of the cloud-based technology or databases have switched from ETL to ELT. So what you have most of the time with databases like Snowflake, BigQuery, ClickHouse is that you load the data first to those databases because they have a lot of storage and compute resources, so they can perform the transformation while they are loaded in the data. So that helps you in speed. For real-time data, you can do that because the former one, the ETL, means that you have to do the transformation because the database is having some kind of limitation in terms of storage and also having limitation in terms of compute. So you need to have done the quality check before. Make sure that only the necessary data is pushed to the database. But unlike the ELT, now you can decide to put in the raw data as it's coming from Instagram, from Facebook, because you know that the database have the compute and the storage power to handle the transformation that you do. And that brings us into tools like dbt that helps you design a model by looking at, and the advantage of dbt is that if you're already good with SQL, the models are designed by writing SQL language. You don't need to learn a new language. You're writing those models using SQL. I think it's only once or twice that there's another language called Ginger, but that is very minimal compared to the amount of SQL or query that you are going to write. So that's what most companies use now in terms of ELT to design their model and to do the whole ETL or ELT processes. And then we have a data pipeline. Data pipeline simply helps us to automate this ETL process. So you design your model, you've already known how you want to push in your data, extract, you want to transform it, you want to load it, or you want to extract, you want to load, and you want to transform. But it's funny that every time you want to do it, especially if you are working with maybe daily data, real-time data, you always have to be the one to go there and manually click run. So you have a data pipeline that helps you to automate this process from the extraction or from the injection of the data to the last point before you visualize it to your maybe Power BI, Tableau, Looker, depending on what you're using as a data analyst. So that helps you in a long way to automate the process, and you put in tests or you put in checks that if the data is delayed or if this one runs before this, then it gives you an error so that at least at the end point, the user doesn't know. Only thing is going to tell you is that, oh, the data did not load for today, because you already put some checks in place that will tell you that maybe the data that was coming in was wrong, so that it doesn't disrupt the stakeholders. It's important to always put those checks so that at least all you need to tell them is, okay, there's a delay, the latest report will come in maybe tomorrow, but at least they don't get to open the dashboard and see not available, not available. That's even worse than showing me the data of yesterday. And then the practical example of data modeling is what we do in terms of customer segmentation. You want to know how much of your product is bought in a particular location. So it's important that you have that column like location. So remembering the address, you're splitting it into city, country, postal code. It helps you at the end of the day to get more insight on customers and know where people are buying from you or where people are using your services the most. Then also for sales, in terms of trend, you can also know how much the revenue is, or what are your top selling products, what are your least selling products, and that helps you to adjust your strategy as a business. Or in inventory, you know when you are running low on particular products because you've structured your model in a way to track the inventory. So you know when you are running short of particular tools and then or particular services or products, and then you are buying and talking to your suppliers to give you those products way ahead of time. So if we move to the pitfalls, the pitfall is it's always important to start small. So less is more. Keep it simple and only add what is necessary in terms of business. So that's why it's always important to talk with the business and also fight back when they're telling you, oh, we want to do something, and you know that the data is not available, and they'll be like, oh, it's in Excel. Why don't you upload Excel? And you know you are designing a model for a database. You say, no, we need to make sure that the data is in the proper method and is pushed to the proper database and connection are correct before you push that data. So that's why it's always important to be open to the expansion of your data model. But it doesn't mean that everything must happen at the same time. You can slowly iterate until you get to that point where you already envisage or where you wanted to get to. Then also always important to document, because at the point in time you can either leave the company or just for people to understand what you have done. And not every time that someone wants to look at the model, they have to call you and say, please, can you explain what is happening here? So it's always important to document so that everyone can know what this represent, how it came about, and how they can modify it. Then also to prioritize scalability. Okay, I already mentioned that is important to accommodate future growth. And then in designing, to avoid hard coding. Like there's a column called this. Instead, use something called alias and use it as a different name. And then so that it is easy for you to go and change the setting in that, but you don't need to go to the code because you already called it a particular name. And it's easy to just change it in the background from the source or wherever it's coming from. And also, the best practices is always to normalize your data model. Even when you want to denormalize, like what I mentioned before, there are sometimes that you have to repeat stuff in your table. You need to normalize the data first. That's create the different entities, do the relationship as much as you can before you now denormalize. And the denormalize is only because you want to make sure that your query or the database is performing as at the speed. You're trying to improve the performance. That's when you start denormalizing. But if you're working with a small database, is just leaving it as it is in the normal form, whether 1 to 3 or from 1 to 6, it's okay to do that. Then also to use consistent and clear naming convention. So that's why if you notice, and when you're working with data, you just make it the plural of the noun. So you're talking about customer, you call the table customers. You're talking about order, you call the tables order, so that it's easy for people to understand. And maybe when you start transforming the data, you need to stick with the particular nomenclature. So you want to you created a view and you want people to easily identify it. You can put in the beginning as a suffix view underscore orders, so that people can easily understand that this is a view. And maybe if it's a table, you can put table underscore or T. But you have to stick to the consistent nomenclature so that throughout the consistency throughout your database, your data model is the same. And also define a clear primary and foreign key. That's important. Then regularly review and define the model. So that's another part that sometimes doesn't happen, but it's important to do that because of data quality, to always go back and review what can we do to save cost, especially now that so many people are using cloud-based technology with Azure, with Snowflakes. They don't mind if you don't review because they're happy if the cost goes up, because there, the more you run it, the more you run, the processing and the storage, the more the prices go up. So based on the company that gives you that particular cloud technology, they're okay with you. But it gets to a point where as a business or as a business owner, you want to reduce those costs so that you can optimize in terms of how much you are spending on the data. So it's always important to review. Are there data that we don't need? You can either archive it or you can delete them. You don't always have to store historical data. You can look at the data. What are those columns that are important? You keep them. The ones that are not, you get rid of them. Or you can actually aggregate it, just trying to see what are the best way to achieve the same thing. Because going forward, the technologies are always improving, things are getting better. You can bring in those new tools and you see that you can save cost as well. And then also always try to optimize performance. So that also helps by reviewing and refining your model. When you do that, you always look at how, though this query, we would have done it this way, because nowadays, for instance, you're writing an SQL query, you can use a common table expression, and that helps you to kind of increase the performance. Or you can change the join. Instead of inner join, you can use a left join, depending on what you are trying to achieve. So those kind of things helps you to increase the performance. Okay, so this is building a simple data model. This is just giving you like a step. If you want to build a very simple data model, you identify the core entities, like for instance, books, author, customer, sales. Then you define the attributes of those entities. So for the books, what is the title, what genre, what's the price of the book, what's the published date. These are also known as columns or fields. That's the attribute. Then now step 3 is to map out the relationship. How is this particular dimension or entity related to this one? How are they connected? So you start doing that connection and voila, you have a data model in a very simple way. Okay, so based on what we discussed, we can decide as an activity, something you can do in your own time, and create a data model, a very simple one, And you can also start from the beginning where you can ask questions to your stakeholders. What is it that you want to achieve? Why are we doing this? How do we do it? Is this the best way to get the data? And what type of technology or data stack do you want to use to achieve that? Okay, I hope with this viewpoint of mine, I haven't confused you about data modeling. And maybe we'll send the slides after, or I don't know.